Okay, another day, another Leetcode. We have climbing stairs. You're climbing a staircase. It takes n steps to reach the top. Okay, so there's x amount of stairs. Okay, n amount of stairs. Each time you can either climb 1 or 2 steps. Okay. And how many distinct ways can you climb to the top? When someone says in how many ways, we're talking about combinations. If we're talking about how many distinct ways, we're talking about permutations. So let's take a look at both. Combinations versus permutations. Combination, the elements of the subset can be listed in any order. In a permutation, the subsets are listed in a specific order. So this is distinct. So let's look at how to get distinct permutations. Total number of distinct permutations are n factorial. Okay. So how do we do factorial? Factorial in Python. Okay, so for I in range 1 to n plus 1, 1 to n plus 1 times I. Oh, because we can't have 0. We just skip 0 for the 1, because 0 factorial is 1. You go 1 factorial, 2 factorial, 3. So it'll be n plus 1. Okay, so let's go for range 1 to n plus 1 I to give us n number of steps. So then we go fact equals fact times I. What do they do after that? Fact times I. Okay, print fact. And then this gets updated by whatever it is. So it's going to be 1 times 2 times 3 times 4 times 5. So we have to replace I with n plus 1 somehow. Or n equals 23. Okay, so n equals 23. We have n. This is already given to us in the equation. And then fact equals 1. Fact equals 1. Oh no, it's not going to do anything. Because it's got to return a value. Return fact. Invalid syntax, so I in range. So case 1 it passes, case 2 it fails. Okay, so why does it fail in case 1 and why doesn't it pass in case 2? So 2, it's just factorial. 1 plus 1, 1 plus 2, n plus 1. So let's look at 3. 1, 1, 1. 1 times 1 plus 2. 2 plus 1. Okay, so finding factorial. Fact is 1. And then 2. So I could do 2 for loops where I find fact is 1. And then fact equals 2. Let's call this fact 1 and fact 2. Let's see if this works. Okay, so fact 1, fact 2. I'm just curious. I'm just playing around with it. So this gives me both the wrong answers, so I have to go backwards. So now we have to figure out what went wrong here. Because when we run it with fact, it works. So if I was to do this, it works for one test case. So now we go to test case 2. 3 is the output. So output is 6. And then this output is 3. 3 combinations. What about the first test case? So look at case 1. It's 2 and 2. N equals 2. So it's 1 times 1. And then 1 times 2. So let's look at, are there hints for this? Hint 1. Think about the step sizes. What could have been your previous step? So if I want to look at the previous step, I could also look at wherever there's a 2, there could be a 1 and a 1. So wherever there's a 2, there could be a 1 and a 1. And then the number of 2's is an n factorial for 1's. Oh yeah, we have n. So we have 1 or 2. Okay, so I'll do this. I'll create a counter. And I'll call the counter 0. Right? So now I'm going to go 4. I in range 0, no 1 to n, because it goes to n steps. It's n steps, it's not an array, it's just a number of steps. They give us an arbitrary number. So, I'll actually use a while loop. While so use counter, and I'll use total. Total perm. So total permutations, and I'll use counter. Because you could either have a combination of one step or two steps. So it'll be one step, or it'll be 1 plus 1, which is 2 steps. Or 2 steps and 1 plus 1. It'll always be 2 steps or 1 plus 1. Or yeah, it'll always be a 2-step or a 1-step. And you just add. So what I will do is I'll create a tracker. So while n is greater than 0, greater than or equal to 0, because when it hits 0, I want to stop. So it can either be 1 or 2. So if n if n minus 2 is greater than 0, if n minus 2 is greater than 0, then I'll go total perm. I'll first minus it, n minus 2, n equals n minus 2, and then I'll go total perm plus 2. So it says if it's greater than 2, then we can have either 1 plus 1, or we could either have a 1 or a 2. So I minus 2 from there, and I add 2 to the total permutations. Here, I'll do this to make it simple. Minus equals 2, total perm plus equals 1, plus equals 2. Elif n minus 1 is greater than 0. You can only have 1. So therefore it's going to be n minus equals 1. Because you can't have 1 or 2 steps. If n minus 2 is greater than 0, then you can have 1 or 2 steps. So that's another combination you have. Total term plus equals 1. Then I want to return total permutations. So with every decrease until it hits 0, we're going to see if we have 1 or 2 possibilities. So let's say it's 32. 32 minus 2 is 0, which means I could either go to 31 or to 30, because I have a large enough number that I could have 2, but you can either only climb 1 or 2 steps. So it's either going to go down to 31 or down to 30 if you go 2 steps at a time. Now my new resting rate is 30. And we keep doing the same thing till we hit 0. Until it hits this edge case here, elif. And if it's not -2, if it's just a -1, then, because once this -2 becomes invalid, then we look for this. If this is the case, then we add another permutation. Because if there's only 1 step left, you can't go down by 2 steps. It's not possible. So you can only add 1 step as a permutation. Let's try running it. Time limit exceeded. Okay, so while n is greater than or equal to 0, total perms, continue. Continue. Let's try that. Oh, because I put greater than 0. Okay, so this also has to be the case where it has to be less than or equal to. Because that could still be a valid case. Let's try that now. I want to avoid creating an infinite loop. Because it should work because, what's it called? You can only have n between 1 and 45 steps. It's greater than or equal to 0 and -2. Let me try this. And then if it goes here, continue. Okay, so now we got a runtime. 2.3 expected 2. I could even take this out. Okay, if I'm going to do that, I'm just going to look at all the 2s I can get rid of. And then if n equals 1, n minus equals 1, total term I'll say greater than 0 here. We'll keep going down by 2. So let's say it's like 3 something. So let's say it's 3. We keep going down by 2's. And then, let's say elif. Or I'll just say, yeah, if n equals 1. Because it's greater than 0 if n equals 1. Then I go n minus equals 1. Total perm plus equals 1. And then return total perm. Done. Oh wait, I should have broken out of that loop. Done. So you see what I'm doing here? If n minus 2 is greater than or equal to 0, so you can't have an even number and it just keeps going down. So you can always have 1 or 2 or 1 or 2 or 1 or 2 or 1 or 2. And you just add 2 to the permutations if it's an even number. If it's an odd number like 31, you go down 1 or 2 or 1 or 2 or 1 or 2. So you always add 2 permutations. When you finally get to the edge case of n equals 1, you just have to add 1 permutation because you can only go 1 step. You can't go 2. And then you break out of the loop because it's greater than n is greater than 0. This is just to make sure you get out of the loop and you return your total permutations that you've accumulated. So let us submit that. What? N equals 4, output 4. Why is it not working here? N equals 4. If n equals 4, let's go through this. N is equal to 4. Output is 4. Expected 5. Okay. So run my test case again. It's accepted. Okay, so what's n equal to here? 2. Okay. And what's it equal to here? 3. Yeah, because if n is greater than 2, add to total permutations. Right? Because it could either be 1 or 2 steps. Then you minus 2. So now you get 1. N is equal to 1, you add 1 permutation. Because you can only have 1 step. So let's say you have 4. If you have 4, my voice is fucked up right now. I don't know why. Let me drink some water. If you have 4, let's see. If you have 4, okay, so let's run it through. 4, n is greater than 0. Right? So n minus 2 is greater than or equal to 0. if n minus 2 is greater than, so if 4 minus 2 is greater than or equal to 0, add 2 permutations, that's 2. And if 4 minus 2 is greater than or equal to 0, add n permutations. Okay, so if this is the case, I could create a base case here. If n, because I guess the base case would be if you go 1 and 2 and 1 and 2, you could have a case where it's all 1s at the end. So if it's an even number, but that doesn't make sense because it works for 2. 1 or 2. 1 or 2 or 1 or 2. So if I'm 4, it could be 1 or 2. So it'll be down to either 3 or 2. And then 1 or 2 again. So it's 4 permutations. What else would it be? I'm just curious if n how could you get 5 from 4? Because 4 could be 1 or 2. Because I go down to 3 or I go down to 2. So that's one, that's 2 right there. And then if I go again from 3, I get 1 and 2 for sure, or 2 and 1. Oh, do you have to get permutations for each? So if I go 2 and 1 and 1 and 2, because technically they consider this, if we look at this, it's 1 and 2 and 2 and 1. So it's not really permutations, it's combinations. Total comm. So now that I look at it as a combination, it could be any order, as long as it's a different order. So 1 and 2 and 2 and 1 are distinct combinations, distinct ways you can climb to the top. So just run it. I passed the test cases. Use test case. Okay, so let's run it. Oh, so you can add this to your used test cases. Okay, so 4 is equal to 5. Probably because you can rearrange 1. I'm curious because with 2, you can only have 1 and 1, or 1 and 2. No, you can only have 1 and 1, or 2. For 3, you can have 1 and 1 and 1. Okay, I see where the issue lies. What do they have here? N equals 3. This is 3 out of 45 test cases. So if n is greater than 3, because that's where you can add an extra base case. I just want to see if this works. N is greater than 3, total comm plus equals 1. So now that should pass this test case. You see? Because once it gets past a certain one, you can reverse these combos into the previous one. So like, for example, if you have 3, you have 1, 1, 1, and you can have 1, 2, and then 2, 1. So with 4, you can do the same thing. So I guess once you hit a certain point, if you're greater than 3, then you have to add an extra one. So let's try it. We're basically guiding our answer based off the test case, because the test case is kind of showing us why it's not working. So let's try submitting it with that. Wrong answer. So see, as you go to each one, so 5 becomes 8. See, so if we go back, 4 is 5, and then 5 is 8. So it would be 5 times, so whatever n is, if n is greater than 3, so it's going to be n plus so if n is greater than 3, so if n is greater than 3, so we got 5 here, n equals 5. So for 4, we just add 1. For 5, we add 2. So for n is equal to 2 plus 1. So 4 minus 3 is 1. 5 minus 3 is 2. So it's going to be n minus 3. Run. It's going to pass this and it's going to pass this. So this is going to be n minus 3. So whatever it adds, it's going to be, you add whatever n is, all those combinations minus that 3. Because once you pass the 3 threshold, you have to start adding the plus 1, plus 2. So I guess if we were at 4, if you look here, the output is 5. If you go to 5, the output is 6. The output is 6, but the expected is 8. So here the output is 5, but the expected is 5. See? So 4 minus 1 is 3, because once you pass 3, you have to start adding those extra combinations. So once you pass 3, because 2 you could only have 2 combinations. 3 you could have is where it starts to flip, and 4 is where we start to see this. So n equals 4, we get an output of 5 combinations. So because we're greater than 3, 4 minus 3 is 1, we add that extra 1 to the thing. So at 5 now, we have 2 extras. So you have to add. So our output is 6, we need to get 8. So 5 minus 3 is 2. We add the 2 extras. So I guess what's going to happen here is 6. 6 minus 3 is 3. So our output's probably going to be, it's going to be, what's it called? So 6 minus 3 is 3. Our output's probably going to be 7, so we're going to have to get an output of 10, right? So with every single one, it goes up. So output of 5, output of this, let's try it. Boom, n equals 5. Okay, so 5, 7, 8. Why didn't that work? Okay, so output is 7. 5 minus 3 is 2. Total combinations. Because I had to create a copy of n. So let's say temp equals n. Let's try that. I just want to see if that works. Submit. Because I don't want to actually decrease n. Okay. Temp minus 3. Okay, so if we can't do it like that, there's got to be another way. We have 2 combinations. So we wanted 2. Well, let us see. let's take these instructions. Because we're getting some of the test cases right. We're getting the base logic right. Let's see what ChatGPT says. ChatGPT. Because let's see how long we've spent. We spent 35 minutes on it, so it's time to take a look. So instructions. Boom. My code. Code's right on track, but has a couple of issues. Let's walk through some. The problem is, it's asking for a number of distinct ways to go to the top of n where you can take either one or two steps at a time. Issues with your code. Your current code counts the total number of steps taken rather than the distinct ways to reach the top, okay? Handling edge cases. Doesn't handle all edge cases, especially when n is 1 or 2, okay? Solve this problem efficiently, you can use a dynamic programming approach. DPI is a way to distinct ways to reach step I. Initialize dp0 equals 1. One way to stay on the ground. And dp1 equals 1. One way to reach the first step. Each step I from 2 to n. There's a number of ways to reach the steps. So to reach some ways to reach steps I minus 1 and I minus 2 is dpi minus 1, dpi minus 2. Revised code. Okay. Okay, so the first step is 1, and the second step is 2. Oh, to stay on the ground. Okay. If n equals 1, return 1. Okay. So let's try this. Let's try, oh, right, wrong one. Got some other code open, so let's try this. If n equals 1, return 1. So we get rid of the base case. So now we're creating a DP, distinct permutation, or something like that. Edge cases, dynamic programming, okay. DP01, okay, so DP0 times n plus 1. So this is what I was trying to go for with what I was doing previously. So the DP dp0 times n plus 1, and then dp0 equals 1. And then dp1, you can only have one way to get to the first step, is 1. So then for I in range 2, oh, so it doesn't actually add anything, it just uses the previous one to get to the next one until we hit the final number. dp is 0 times n plus 1. Oh, 0 times n plus 1. So we're just filling up an array of zeros times n plus 1. So if it's 10 spaces, it's going to be 0 times 11 is what they're trying to do. So dp at 0 and 1, then we fill that up. So we know the array is going to be at least 2. And then it's whatever n minus 1 is, because we went to n plus 1. Because the array is 0 indexed. So it goes to n minus 1. So n plus 1 basically gets us to n on the array. So let's do this. So for I in range 2 to n plus 1. Then we go dp so dp at I equals dp I minus 1 plus dp I minus 2. So we take the previous two additions. Then we return dpn. Let's try. Boom. So basically what it's doing is you want to get an array, and that array will hold the number of combinations at each step. So at 0, it's going to be 1 at max. That's the way to stay in the ground. At 1, it's going to be 1. At 2, then it's going to be 1 plus 1, right? So 1 plus 1 is going to be 2. So dp at 2. So at the second step is going to be 1 plus 1. So 1, dp at 2 is going to be dp 1 plus 1. So that's going to give you 2 steps. So you add that to the dp2. dp3, dp at 3. So the third step is going to be 2 plus the 1. So that's going to give you 3 combinations. And then 4 will be 3 plus 2. And then 5 will be 5 plus 3, which is 8. And that keeps going all the way until you hit the edge case. So if you go to the wrong answer now, we submit this, it should pass everything. You see? So it took the original approach that I had, but it uses dynamic programming. Dynamic programming means it adjusts as you go per each iteration. So it's looking at new values for every iteration. So as I go to the next item in my array, I'm looking at the previous 2. If I go to the next item in the array, I'm looking at new previous 2. So this is dynamic because it's always changing as the program progresses. So yeah, that's the solution. We ended up using ChatGPT because we passed the time limit, and I'm going to keep doing these. As we hit past 30 minutes, I'm just going to try and look at the solutions and understand that over time, once I do a few hundred of these, it's just going to come like naturally. I'm going to build like the mindset to think algorithmically when I'm solving these questions. This is the goal of this channel. It's not to just give you question answer like all these other channels. I'm trying to share with you my thought process and how I progress as I keep solving these problems. And once I keep solving these problems, you're going to see that the volume creates quality in your solution. So as I do more and more and more of these, I get more adept at solving them, and I can give you the best possible solution in the future. So if you like the video, please give it a thumbs up. If you have any feedback, please leave it in the comments below. And don't forget to subscribe. Thank you.